Chapter 11. So Chapter 11 deals with, first off, parametric equations. So something like this. So x equals f of t, which is equal to 2 times t, and y equals g of t, which is 1/2 t squared minus 4. And we want this for t values in between 0 and 8. So what we can do is we can make a chart. So we have our t, we have the x, and then we have the y. And so we have our numbers for t. 5, 6, 7, and 8. And then we would take these numbers and we can plug them in. So if I plug in first to the x equation, well, 2 times 0 is going to be 0. And then this is going to be 2, 4, 6, 8, 10, 12, 14, and 16. And then we could do the same thing in terms of our y equation. And so here we would get minus 4, minus 3, minus 2.5, 4, 8.5, 14, 20.5, and then lastly 28, right? So maybe you think of this in terms of maybe an equation dealing with a projectile. And so we would have how far it traveled in the x direction and how far it's traveled in the y direction over a time frame from 0 to 8. That's what this is telling us. Okay? So then other examples of this stuff. So another example. We could have one like this. X equals 4 cosine pi t over 15. And y equals 4 sine pi t over 15. And here, t in between 0 and 30. Okay? And this will give a circle. Okay. So you could think in terms of this equation for something like a Ferris wheel and where you are on in terms of position on that Ferris wheel. Okay? Okay. So parametric equation. Of a line will be in x equals x naught plus a times t, and y equals y naught b times t. Okay. Okay. Well, we can also take derivatives of parametrics. And so we have dy dx is going to be dy dt over dx dt. So it'll be the derivative of the one with respect to t, and then the derivative of the other one with respect to t. So let's look at an example here. So if I say x equals 3 sine t and y equals 3 cosine t, and so dy dt would be minus 3 sine t dx dt is going to be 3 cosine t. And so dy dx is going to be minus 3 sine t over 3 cosine t. And this will simplify to the negative tangent t. So parametrics. All right. Well, the other thing you'll see in this chapter is going on about polar coordinates. Okay. So rectangular coordinates is in the form of x, y. And then polar is going to be in the form of r and theta. Okay. So to make these conversions, we're going to use these formulas. And so we have x is going to be r cosine theta. Y equals r sine theta. Okay. Tan theta is equal to y over x, and theta is the inverse tangent of y over x. And we also have that r squared equals x squared plus y squared. And r then would be the square root of x squared plus y squared. Right? So we have that. Right? Okay. So let's look at an example as to how do I do this conversion. So let's say we want to convert the point 3, 4 to polar. Well, r is going to be the square root of 3 squared plus 4 squared. So this is going to give us 5. And then theta is going to be the inverse tangent of 4 over 3. And this will come out to be 0.927, and this is in radians. Okay. So my point will be 5, 0.927. Okay. And then if we wanted to convert going the other way, so now we're going to convert 5, 4 pi over 3, and we want to convert this to rectangular. So x is going to be 5 cosine 4 pi over 3. And this will give us a minus 2.5. And y would be 5 sine 4 pi over 3. And this will give us a minus 4.33. So my point will be minus 2.5 minus 4.33. So we can get from rectangular to polar and then from polar to rectangular. Right? So we can go back and forth in terms of that. Right? Right? The other thing that is we can graph polar equations. And so graphing polar equations So if I wanted to graph something like this, and now my polar equation is going to be in this form. So I'll have an equation that is going to look like that. All right. And so for this, let's go here and see if this works. All right. So now hopefully we're looking at my Desmos screen here. Hopefully this is working. But we're going to see what happens when I graph a polar equation. So we go to desmos.com. We're going to go to graphing calculator. It'll pull up this. We want to change this into a polar graph paper. So we're going to go here on this little wrench tool, and we're going to change this into polar. And so now we get a polar grid. And we're going to type in that equation and see if we can get this to work. Right? So R is going to equal 1 plus 3. And we want our sine function. So let's go down here to functions. And we want sine. And then we need our angle, which is theta. So click on this ABC thing, and we get the little theta symbol there. And we get our polar graph. And so we get this shape that shows up in terms of our graph. Right? Right? And so let's put this graph, sort of make a quick version of that graph here on my whiteboard. Right? Right? And so my graph looks something like that, right? So polar graphs, you get some fairly interesting shapes that you can occur, like this one that we see here in terms of this, right? Right. So here, if you're going to graph and you're doing it by hand on polar graph paper, you barely have to cover angles all the way from 0 to 2 pi. And so you need to pick a variety of angles from 0 to 2 pi to make this work, to get this graph. Right? All right. So let's go back to just my one screen for now. Right? And so we should be back on the main screen here in my graph that I drew. Right? All right. Right. So we can also look in terms of derivatives here. So we can find the slope of a tangent line. Again, remember, slope is derivative. And so now we have this equation, dy dx is going to be the derivative evaluated at theta, sine of theta, plus the function evaluated at theta, cosine theta, over derivative at theta, cosine theta, minus f theta times sine theta. Okay. So let's look at the one I just made my graph of. And so we had R was equal to 1 plus 3 sine theta, which means then dr d theta is going to be 3 cosine theta. Right? And so let's say, for the sake of argument for this one, I want to know the slope of the tangent line when theta is equal to pi over 3. All right. So we want to get that, pi over 3. All right. So let's start plugging in. So this means we're going to have 3 cosine pi over 3 sine pi over 3 plus 1 plus 3 sine pi over 3 cosine pi over 3 over 3 cosine pi over 3 cosine pi over 3 minus 1 plus 3 sine pi over 3 sine pi over 3, right? So if I start plugging in the numbers, well, this would be 1.5 times 8.866 plus, this is going to be 3.598 times 0.5 over 1.5 times 0.05 0.5. Let me fix that. Right. So it'll be 0.5 minus 3.598 times 0.866. Right. And so if we do that out, we end up that on the top, we get 3.098 and then on the bottom we get a minus 2 point, and we'll call this 366. And so 3.098 divided by the negative 2.366, we get a slope of negative 1 point, and we'll call it 3.1 at that point, all right? So that would be the slope of my tangent line at that point, right? Right? Other things we can do with this is we can also find the area. And so the area is alpha to beta. Not very good beta. Try that again. There we go. 1/2 f of theta squared minus g theta squared. Right? So, for example, let's say we want to find in terms of this 3 sine theta and r equals 3 cosine theta. Right? And if we were to put these on a graph, these are both circles. The 3 sine theta is going to be a circle like this, and the 3 cosine theta is going to be a circle like that, right? So we want to find in terms of this area where they overlap. So I want to know what is the area right in there, that part there, right? So we need to know the intersection points, right? And so to do that, well, we have 3 sine theta equals 3 cosine theta. Well, we can divide everything by 3, and so divide by 3, divide by 3. sine theta is going to equal cosine theta. Okay. And then if I divide, we have that sine theta, which of course this is tan theta, is going to equal 1. And tan theta here, theta would end up being, if you remember, would be pi over 4. Okay. So we're going to integrate 0 to pi over 4, 1/2, 3 cosine theta squared minus 3 sine theta squared d theta. Well, the half we can pull out front, so 1/2, 0 to pi over 4. This is going to be 9 cosine squared minus 9 sine squared. And then, of course, the 9 we could pull out front. So this is going to give me 9/2, 0 to pi over 4, cosine squared minus sine squared. And so then when I integrate this, this will give me 9/2. And cosine squared, this is going to be theta over 2 plus sine of 2 theta over 4 minus theta over 2 cosine minus sine of 2 theta over 4. And then this is evaluated from 0 to pi over 4. Well, you see that the theta over 2's go away, and sine 2 theta over 4 minus a minus sine 2 theta over 4 is going to give me 2 sine 2 theta over 4, 0 to pi over 4. And then we have our 9/2 out front. And so this will end up being 9/2, 2, and so the 2, let's get rid of the 2. Let's simplify this a bit. After all, 9/2 times 2, well, that's just going to make this 9. And so this will be, let's leave it for 9/2. Let's leave it for the moment. So this is going to be 2 sine of 2 theta pi over 4. That'll be pi over 2 when I do that. Over 4, right, for that, minus 2 sine 2 times 0 over 4. Right. So this is 9/2, 2 sine pi over 2 over 4. Ends up being pi over 8. Let's see. Well, 2 times 0 is 0. The sine of 0 is 0, so I don't have to worry about the back term right, at the moment. So we have this. So this is going to be 9 sine pi over 8. And if we plug that in, so 9 sine we end up at 3 point, we'll call it 44 for that. All right. And then the last section deals with the conic sections. So my last section deals with that stuff, right? Our conics, right? So we have in terms of parabolas, hyperbolas, and ellipses. So first off, parabola. So two types. One is in the form of x squared equals 4py. And then the other type is y squared equals 4px. Right? So the ones that are the first type, they're going to be the parabola that is in this kind of shape. And then the other one is going to be the parabola that opens in the other way. And so here, if p is greater than 0, it opens up. P is less than 0, it opens down. And then over here, we have that if P is greater than 0, opens right. And P is less than 0, it opens left. So that in terms of our parabola, so we have something like this. Find the equation of the parabola. With the vertex is at 0, 0. So here we're talking about the vertex at 0, 0. And the vertex is that thing at the bottom of the curve. Right, right. And goes through the point. And opens downward. So we have our equation. So we got, this is x squared equals 4py. We have a point, and so we have 2 squared equals 4p times minus 3. So 4 equals minus 12p. And then we divide. And so P, we get a negative 1/3 is equal to P. And so that would mean that our equation was x squared equals minus 4/3 y would be the equation that went with that. All right. So we found our equation of our parabola that goes with that information. All right. All right. All right. All right. So then the next type then is an ellipse. So an ellipse, right? And so an ellipse, then, we'd have, again, 2 basic types that we can have here. So let's draw a couple of quick graphs in terms of an ellipse. Right? And let's see, let's do one going like this. So we can have one ellipse going like this. And then the other type would then be going like that. Okay? So again, whether the major axis is on the x or the major axis is on the y. That's what we're looking at here. Okay? Right. So we're going to go through then on this. So my equation is going to be, first off, for the one major axis is on the x, we'll have the equation is going to be in this form. It's going to be x squared over a squared plus y squared over b squared is equal to 1. Okay. And here the major axis is horizontal. So let's label some stuff on my graph here. So this point is going to be the point A0. This is going to be negative A0. And then this one is going to be 0B. This one is going to be 0, negative B. And then we have these two here. This is going to be C0, and this will be minus C0. Okay. And then in terms of my one running in the opposite direction, okay. So now, again, so we're going to have here, my equation is now in this form, y squared over a squared, x squared over b squared equals 1. And again, we can label our points here. So this is going to be 0a. This is going to be 0, negative a. This is going to be b0. This one over here would be minus b0. And then we have 0c. And down here, 0, negative c for all those points, right? And so we get that, right? Now, the other thing here that goes along with this is this equation, that is, and this is true for both, and that is that a squared is equal to b squared plus c squared, or c squared is equal to a squared minus b squared. Right? So then, given something like this, so let's say we're given that x squared over 9, y squared over 4 equals 1. I want to know all the vertices for this. So the vertices are going to be 3, 0 and minus 3, 0. And then the other two will be 0, 2, 0, negative 2. Okay. And then if I want to know the length of the major and minor axis, the length of the major, well, from negative 3 to positive 3, that's going to be 6. And then the length of the minor axis, well, from 2 to negative 2, that will be 4. Right? And then if I want to know my foci, which is what those values of c are called, those are your foci. And so we have that c squared is going to equal 9 minus 4. So c squared is equal to 5. So c is going to be the square root of 5. And so my foci are going to be at the square root of 5, 0, and negative square root of 5, 0. Right. So we get that. Right? Right. And so then that leaves us with hyperbolas. And so we get to hyperbolas. And so again, let's draw a couple of quick graphs for these. Okay. So the first one will be one that's going like this and like this. And then the other one would be a type going like this and like that. Right? Right? And the other thing about our hyperbolas is we're going to have some asymptote lines. So there'll be one here, and there'll be one going this way, and then the same thing here. There'll be one there, and then there'll be another one going that way. Right? So we'll have some asymptote lines in here. All right. So let's get to our equations for these. So this one will be in the form of x squared over a squared, y squared over b squared equals 1. Okay. And the asymptotes will be y equals minus bx over a and y equals bx over a. And then over here on the other side, we'll have that our equation is going to be y squared over a squared, x squared over b squared equals 1. And my asymptotes will be y equals ax over b and y equals negative ax over b. Right? Will be those two. Right? 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 So we have in terms of our equations then of our hyperbola. Right? Well, the other thing then is we can look at in terms of our in terms of these equations in polar form. And where is it in here? Polar equations. There we go. Okay. Let's see if this will copy or not. Come on. No. Trying to see if I can copy something out of the book and post it into this video or not. All right. Let's see if this will work. All right. Right. Yeah. Right. Nope, sorry. And we want to go. Yeah. It didn't work. All right. That's not going to work. All right. So let me go here then. Let me do like I did before. Let's see if hopefully this will work. So we're going to go to the second screen. I didn't want to have to rewrite all of this. Right? All right. So we should hopefully be on the second screen. And you have here, and this is in your book, but the polar equations of the conic sections in this form. Right? Right? And so we have the, then I want to have to rewrite the whole thing out when you have it here. But the one thing here, though, about the polar form of our equations is this, the part at the bottom, which says that if 0 less than e less than 1, then we have an ellipse. If e is equal to 1, then it's a parabola. And then if e is greater than 1, it is a hyperbola. Right? Right. So we have the polar form of our conic sections. And the e value typically will tell you whether you have the ellipse, parabola, or an hyperbola. All right. All right. Let's go back to my main screen. And that will conclude this video.